Okay, so everybody should have a Plate Tectonics Doodle Notes sheet. I want to point out that this is just the template and we're going to fill it in. You can add some colors, you can write in different colors. It's totally up to you. But first let's point out right here that this is about plate tectonics. So this arrow is going to point us to our, just like an explanation, kind of what it is, okay? So it's interactions of the Earth's lithosphere that slide over the asthenosphere because of convection in the mantle. Okay, so last week we talked about Earth's layers, and remember that the asthenosphere is underneath the lithosphere. So it is moving because of convection, and convection is a difference in temperature, and so because it's moving, it's causing whatever on top of it to move, really slowly. So here we see plate tectonics. We kind of told kind of like a definition of it, and this is where it says like what is it, okay? So remember when we talked about sketch noting, this is a good example of how things kind of stand out, okay? So over here in this section we're going to talk about the evidence. I'm just going to do some bullet points, okay? So fossils have shown that Pangea occurred, remember, so that all of the land pieces were at one point connected. Okay, we also know that plate tectonics shows locations of volcanoes and earthquakes. So if we look at where those locations are on a map, we will see that there is a relationship based on the lithosphere and where those occur. Okay, sea floor spreading also shows evidence of plate tectonics, and the continent shapes show that they look like puzzle pieces. Alright, so what happens when plates move? So up here we talked about that it's moving because of the convection in the mantle. So Earth's surface slowly changes. Alright, slowly changes. Now remember, this is a slow process because consider the amount of movement it would take to move pieces of the lithosphere. Okay, so produces earthquakes and volcanoes. So again, we're looking at what happens when plates move. Alright, so this is the question that we're looking at. So Earth's surface, what we live on, is changing slowly. When that's happening, we're producing earthquakes. We form mountains. Or not we, I'm sorry. And Miss Myra can't spell. when the plates move, they form mountains and they make ocean basins. Okay, so think about the boundaries that were mentioned in the video and how these are how Earth's surface is changing when the plates move. Okay, so the plates are going to be moving and that is causing changes. So why do the plates move? And that would be because of convection currents in the mantle drive plate movement. You could say drive, you could put cause. Okay, so I want you to think about how you may have seen pictures or diagrams of mantle convection, and it shows these arrows that are constantly moving.
Nathaniel Barbo, would you please come to the front office? Your ride is here.
Sorry about that. Okay, so when things move, they're shown by arrows, right? So the mantle is hot, so hot things rise to the top and it pushes the other material back down. So it's a constant movement. So that since there's movement here in the mantle, whatever is up here is also going to be pushed and moved. Alright, so there are 3 different types of plate boundaries, alright, to keep in mind. So first we're going to go over here where these arrows are, and we're going to talk about convergent boundaries. Okay, convergent, as you can see, is where the plates are moving towards each other. Okay, so what happens, or what can happen, when the plates move towards each other? There can be volcanoes, okay, mountains. These are the most common kind, so I'm going to put, alright, earthquakes. This is all possible, okay? You can have islands formed and deep ocean trenches. Alright, the crust is destroyed. Think about it. It's being pushed together. So what happens when you and another person are pushed together? You're hurt, right? At some point in time. So think about a piece of land that is being pushed together. So it's going to get destroyed. It's not going to stay the same. So all of this stuff is also explaining like how Earth has changed over time. Okay? How it is changing. Alright? So now let's look at the next one. If you look at the arrows, they're sliding past each other. Okay? So one plate is moving this way, the other plate is moving that way. The most common thing that forms at a transform boundary are earthquakes. The stress and the tension from moving in opposite directions causes a sudden release, and that is where you have earthquakes. Okay? Now the crust here, alright, can neither be created nor destroyed. Now, if you have an earthquake, yes, the crust could be, changed. But at a transform boundary, you're not going to have any new land formed. Okay, new land is not going to form there. All right. So on to our third boundary, divergent. Notice that they are going away from each other. They're not mad at each other. They're just moving in different directions. Okay. So you can have a rift zone, you can have mid-ocean ridges, and this is where we see a lot of sea floor spreading. Think about it. Spreading, all right, the plates are spreading apart. So here is where that new ocean floor is going to be made, because it's going to make a gap. And magma is going to come up and it's going to cool and it's going to make new crust. Okay? New crust can be created at a divergent boundary, usually right where the plates have separated. Okay? Now, let's talk a little bit more about Pangea. Alright, so what is Pangea? Alright, it is our super continent. Not because it's like super great, but because it just ends up being like one big continent. Alright, so it's made up of all the continents. So remember, the theory is that it was all one big continent, and now it has, well, not now, but eventually they moved away from each other because of plate movement, okay? So over on this side, we're going to talk about how, because remember, we're still talking about plate tectonics, how plate tectonics explains how they broke apart and moved to where they are now. So think about the Pangea activity and how all the puzzle pieces kind of, fit together, and so then they were all together, and then as the tectonic plates started to move, then things started to spread, and then new ocean floor was made, and then, think about it. If there was water all over here, okay, and then they start to move away, water is going to fill in those spaces. So tectonic plate movement actually caused the continents to drift apart, and that was the theory for a long time, and so now we actually have the evidence. Okay, so remember up here we talked about the evidence that is actually there. We looked at, there's fossils, there's also rock evidence, so we can put rock strata that shows us how things have changed over time. Alright, so this, make sure that you add some color to it, kind of review all the parts of plate tectonics, and you're going to put this in your notebook.